Hello everyone, and welcome to Lab Manager's Tech Trends webinar series. My name is Trevor Henderson, Technology Editor for Lab Manager, and I'll be moderating today's discussion, which will focus on the latest trends in forensic science techniques. Today we have a panel consisting of three leading industry specialists who will discuss some of the recent developments in forensic science. We like our webinars to be very interactive, so we encourage you to send us your questions at any point during the presentation, and we will address these during the question and answer session following the presentation. To ask questions, simply type your query into the question box, which is located at the bottom left-hand side of your screen. We'll try to address as many questions as possible during the Q&A session, and if we happen to run out of time, I'll forward any unanswered questions to the panelists, and they can respond to you directly. Additional resources can be accessed through the resource window, which is located on the left-hand side of your screen. You may also move or resize any of the windows simply by grabbing them at the top or stretching them at the bottom right corner. At this time, you may need to move or minimize some of the open windows to see the live view. This webinar recording will be available early next week on Lab Manager's website, and at the end of this webinar, we'll share that link with you, as well as the contact information for all of our panelists. Before we move on to today's presentations, I'd like to draw your attention again to the resource area. As a sponsor of this webinar, PitCon 2016 has kindly provided us with a number of resources, including a listing of all the forensic short courses being offered this March in Atlanta, as well as a link to their registration page. Please make sure to download these resources if you're planning to attend. And with that, let me introduce our first speaker. Joseph Kennedy has over 30 years of experience in chromatographic purification techniques. He has numerous publications in the area of chiral separations and purification and is currently Senior Scientist with Prosolia. In his current position, he is involved with development and implementation of the Velox 360 paper spray system, as well as desorption electrospray ionization for molecular imaging. His current research interests include forensic applications such as identification and quantitation of cannabinoids of drugs of abuse and biological fluids, quantitation of antibiotics and other drugs in staple foods such as milk, and identification of biomarkers for different diseases using molecular imaging techniques. Joe, thank you for joining us today.
Thank you. Today I'm going to be talking about some screen techniques which I have developed for looking for cannabinoids and cathinones and biological materials. Just a quick outline of what we're going to be going over today. I want to introduce you to paper spray ionization, which you may not be familiar with, and try to show you how it's different from some current practices. I'll have some examples of how that technique can be used for qualitative as well as quantitative analysis. We're going to talk about sample preparation that I use to prepare some herbal samples which were collected at some different crime scenes. I'll then show you some high-resolution mass spec and MS2 spectrum from some of the cannabinoids which were identified in these herbal samples, and then finish that up with a summary and acknowledgement. So let's get started. For those of you who are not familiar with paper spray, most of you are familiar with a traditional analysis of biological fluids. We take blood, for example. We'll have the blood sample. We'll isolate plasma from that. There'll be some type of sample pretreatment, which could be protein precipitation, a solid phase extraction, or maybe even a liquid-liquid extraction, and then a traditional LC-MS analysis to get our results. What we're trying to do with paper spray is to basically simplify that whole process. So we have designed some cartridges which allow you to deposit microliters of that biological fluid directly onto a cartridge and let it dry. Then we do a direct analysis off the cartridge, and that analysis takes less than a minute. Once the sample is on the cartridge, we found that there are also stable, and it can be transferred to other locations. So if a sample was taken in a location which did not have access to a mass spectrometer, it would be easy to package that sample up and ship it someplace else that might have one that could do the analysis. Well, how does paper spray work? Paper spray ionization involves depositing your sample on a porous substrate such as paper, An extraction spray solvent is then applied to that paper so that the paper is saturated. We then put a voltage on the paper, and since the paper is cut to a sharp tip and there is a voltage drop between that tip and the inlet of the mass spectrometer, we can generate an electrospray off of that paper substrate, and we can get a mass spectrum. And the image to the right is an actual photograph of that electrospray process in a mass spectrometer. The Velox 360 system, which I've been working on, automates this entire process. We have a magazine which holds up to 40 cartridges. We have a carousel system within the unit that allows us to take the sample and move it around, deposit liquid on the sample, move it in front of the mass spectrometer, apply the voltage, and then once the analysis is complete, the cartridge is ejected and the next sample is processed. So this whole process is timed, and it turns out to be a very reproducible way of doing the paper spray ionization process. Now I'm going to show you a few examples of how the technique is being used. The first example is looking for drugs of abuse in a substance like urine. In this case, 5 microliters of urine was deposited on the cartridge. The urine was then analyzed directly without any other sample preparation. The analysis time was about 65 seconds. In the sample, we see methamphetamine, tramadol, EDDP, methadone, fairly typical things you might find looking for drugs of abuse and a urine sample. This data was collected on a Thermo Scientific Exactive mass spectrometer. The drugs in this case were all identified by accurate mass and confirmed by LCMS. This is another example. Compliance monitoring is something that many toxicology labs are involved with. In this case, we're looking at a methadone clinic. Methadone clinic, we take a urine sample and we are interested in making sure that our patient is indeed taking the methadone as prescribed, and if they are, we should see methadone and EDDP in their urine. And in this case, we see that 5 of the patients tested all contained methadone, but that 6th patient was probably not taking his methadone, but he was taking cocaine and several other illicit drugs. So this was a very quick way to do monitoring of the urine from a compliance standpoint and get a real quick read of whether our patient is indeed taking the drug as prescribed. Now, one of the questions that is asked most often is, these are qualitative examples. Can this technique be used in a quantitative manner? And the answer to that is absolutely yes, it can. We would do the quantitative analysis just like you would do your traditional LCMS analysis. We'd typically use the internal standard just like you would with your LCMS analysis. In this example, which I have displayed, I have spiked a series of synthetic cathinones in urine, and I've added an internal standard to the cartridge prior to the analysis and generated calibration curves for each. And you can see the R-squared values are very good for all the compounds. And then looking at the accuracy of the measurement at a 20 ppb level, we see that we also have very good accuracy for all of these compounds at that level. So the technique can certainly be used for quantitative as well as qualitative analysis. For the purpose of this study, we received some samples that were seized at different crime scenes, and some of them were from some post-mortem crime scenes. They were herbal incense or powders. The samples were homogenized. Then a amount of liquid was added. The extraction solvent in this case was a 1-to-1 mixture of methanol and acetonitrile. 10 microliters of that extract was deposited on a cartridge and allowed to dry. The samples were then packaged up and shipped from Indiana, which is where I'm located, out to California for analysis. The experimental process for doing this is as follows. I had a Velox 360 system. It was mounted on a Thermo Fisher Q-Exactive Focus. The solvent mix that I used to do the analysis with was a 90-10 0.1% acetonitrile water, acetic acid mix. That was used for both spray and extract. The Q-Exactive was set up to run in a full scan, data-dependent MS2 mode, and I was using an inclusion table which contained 39 cannabinoids, cathinones, and the data was acquired using the Thermo Fisher Scientific Trace Finder software. The paper spray process, basically, this is what a paper spray chronogram would look like. As soon as the cartridge is moved in front of the mass spectrometer, there is a period of time which we have no voltage applied, and that would be highlighted in the blue. When the voltage is applied to the cartridge, we see a signal, and that is, of course, the middle region, and the signal was generated after placing 5 kV on the cartridge. We then turn the voltage off for a period of time, and then we put a negative pulse of 5 kV at the end of the run, and this is to basically eliminate any potential charging of the mass spec capillary which might occur throughout the process. The spectrum at the bottom is from one of the samples that was in this study. It was a sample called Tranquility, and this sample contained one of the bath salts, methylone. And I want to talk about this particular example just a little bit more later in the talk. The first and second generation cannabinoids were primarily JWH-018 and 073 as illustrated here on this slide. Now, many of these compounds have been around for a long time, and they have been classified as controlled substances, so we don't typically see these in herbal blends anymore. They've been legislated essentially out of existence. There are some newer generation cannabinoids, which I have illustrated on this screen, and you can see they're quite different than 18 and 73, containing quite different functionality. These were the focus of this particular study. These were the ones that we were looking for in these seized samples. We're interested in determining if we could find any of these compounds in the samples. One of the interesting things about the cannabinoids in general is they fragment in a fairly predictable fashion. They tend to fragment on both sides of the ketone linker. So if we know what the two side chains are, we can predict what the fragments should be. And on this slide, I've shown a fragmentation of JWH-018, and we can see it fragments exactly as expected. And we see the fragments as predicted on the slide. We see those coming up. So, process we're going to be used for detection and ID of cannabinoids. First of all, we run the sample. Does the formula match anything in the conclusion table? If the answer to that is yes, then we get a fragmentation MS2 pattern, our method we have set up. If after the samples are run, we wanted to go back and look at the accurate mass data and see if there are any unknowns we might be able to identify, we can certainly do that. And that was exactly the case with the methylone in the earlier slide. We did not have this compound in our inclusion table. And so when we looked at the mass spectrum, we found that was the primary component, and we were able to identify that by accurate mass, but we just couldn't get confirmation by MS2 for that particular cathinone. This is a high-resolution accurate mass spectrum from Bizarro, which is one of the herbal blends that we were able to analyze. This was found to contain XLR11 and PB22, which are two of the third-generation cannabinoids. So the accurate mass gave us the expected formulas for these two compounds. This is the fragmentation for XLR11, and as you can see, we got exactly what we were expecting. MZ125 and 232 were the desired fragments. These were also identified by accurate mass as well. So we have another confirmation that it is indeed XLR11. PB22 is an analog of JWH-018. The ester linkage is slightly different in the indole position, but it also fragments as expected, and we see the 214 and 144 as being the two predominant peaks in MS2 for this particular cannabinoid. This is another example, high-resolution mass spectrum of black magic smoke, which was another of the herbal blends. This was found to contain UR144, A796260, and MAM220. All these compounds were identified by accurate mass. And the next slide depicts the MS2 spectrum for UR144. We can see it again, fragments as expected, generating the fragments 214 and 232. MAM220, again, 169 and 232 were the primary fragments as depicted. And I think I missed one of the spectrum, but it's not really that important. It just basically shows the same thing we had seen in the previous two examples. We were able to identify the fragments as well, and they were as predicted. Similar results for all of these samples were obtained using a UPLC TOF MS method. And this table is kind of busy, so you may not be able to read all the entries. But the important carry out from this was that all of the main cannabinoids and all the blends were identified by both techniques. The ones I have highlighted in red were samples where we were able to identify some additional cannabinoids by paper spray that we didn't see by UPLC MS. The last three examples with the asterisks were not run by UPLC MS. They were only run by the paper spray, but these were primarily older first-generation K2 blonde, things like that, which have been run by UPLC TOF a number of times, and JW8, 018, and 073 were the primary cannabinoids in those blends. So just to summarize, what I hope that I've shown you in this presentation is that paper spray MS provides a rapid analysis technique with minimal sample preparation. Samples are stable on the Velox cartridges after they're dry. This gives you the ability to ship them to other locations to do the analysis with. If you combine paper spray ionization with a mass spectrometer like a Q-Exactive Focus, it provides a very simple workflow for the rapid screening and identification by accurate mass and MS2 for compounds. This greatly aids in the identification of these type compounds and mixes where standards may not be available. High-resolution accurate mass data, which is obtained by this technique, allows for post-run identification of any unknown components which you might not be looking for but might be surprised to find. The analysis times for paper spray MS are on the order of seconds rather than minutes with traditional separation techniques. And we see very good comparative data between traditional LCMS and paper spray for all samples. So I'd like to acknowledge Kevin Shanks, who's a forensic toxicologist at AIT Laboratory. He provided me with the samples and also the comparative UPLC MS data. If you'd like further information about the Velox 360 system, that can be obtained at our website, www.persolia.com, and more information about the Thermo Fisher Q-Exactive Focus can be obtained at their website, which is www.thermoscientific.com. And I thank you very much for your attention.
Well, thank you, Joe, and thank you all for sending in your questions. I encourage you to continue to do this throughout the presentations. And if you're joining us late, you may ask questions of Joe or any of our other presenters simply by typing your query into the question box, which is located at the bottom left-hand side of your screen. Our next speaker today joins us from Agilent Technologies. Dr. Thomas Glodenis earned his Ph.D. in analytical chemistry from the University of Massachusetts, Amherst, and an executive MBA at St. Joseph's University's Hobbs School of Business. He has been with Agilent Technologies for 17 years, serving in a number of positions, including the Director of Agilent's Homeland Security Program and Global Marketing Manager for Forensics and Forensic Toxicology. Tom is a member of the American Academy of Forensic Sciences, the Society of Forensic Toxicologists, the International Association of Forensic Toxicologists, and ASTM E30 Committee on Forensic Sciences. Additionally, Dr. Glow-Dennis has been appointed to serve on the Chemistry Instrumental Analysis Scientific Area Committee's Controlled Substances Subcommittee of the NIST Organization of Scientific Area Committees. Thank you for joining us today.
Thank you so much for that kind introduction, and thank you to everybody this afternoon for tuning in to hear these presentations. Skating on the back of the presentation you've just seen, I'm going to speak a little bit more deeply about this entire concept of screening for unknowns. And you've heard that mentioned a couple of times already today, with the objective of putting your unknowns to rest, the new paradigm for screening forensic toxicological samples. Looking at a traditional analytical workflow, I'm sure this is familiar to all of you. I'm going to focus in on the screening portion in the second box. Going back historically, screening was done using a number of different colorimetric or microcrystal techniques, is still used in controlled substances world today. Moved on to immunoassays. Given some of the availability of kits and for other reasons, immunoassay screening was supplemented with GCMS as mass spectrometric techniques became more accepted. And many of us in our laboratories today do some form of immunoassay screening with what we often call a comprehensive GCMS screen. And what we've rapidly come to find, particularly in today's world, is that our comprehensive GCMS screen is maybe not as comprehensive as we once thought. And so in our laboratories, we've begun to supplement that with the use of LCMS techniques, particularly LC triple quads, where we use some form of multiple reaction monitoring to supplement or to complement the screening that we get from our immunoassay and GCMS systems. As we continue to look toward the future, we find ourselves in situations where we may not always be looking for targeted compounds. We saw some examples in the previous presentation where some unexpected results were identified, and we're finding that more and more, in particular in the world that we live in today. We're looking for needles in a haystack, if we will. And this is requiring that we consider different mechanisms, different paradigms for undertaking screening in our laboratories. So what is driving this change in paradigm? Well, number one is, as many of you have seen, that prescription drug abuse is becoming a major problem in the United States, if not globally. In fact, the Centers of Disease Control and Prevention has classified prescription drug abuse as an epidemic, and we're seeing more and more of these prescription entities showing up in our laboratory. And to supplement that, we, of course, have this issue of designer drugs, to the extent that the United Nations Office of Drugs and Crime have called it an unprecedented expansion of synthetic drugs that is taking an ever greater share of the illicit drugs market. So with all these new unknowns flooding into our laboratories, it requires new tools, new technologies in order to be able to identify some of these materials. Hence, the advent of TOF, time of flight, or QTOF, quadrupole time of flight, either as a detector used for liquid chromatography, LC, or gas chromatography, GC. These can be used as targeted screening techniques with extensive libraries that are available today in upwards of tens to 20s of thousands of compounds. Or, unlike the screening protocols of the past, they enable true unknown screening. The ability to measure accurate mass yields a molecular formula. And then to complement that molecular formula, the quadrupole portion of a QTOF provides structural information through fragmentation, just as in LC triple quad. Furthermore, these techniques provide all the data all the time. It screens the entire sample. There's no need to elicitate certain targets. One could look at everything in the sample so that if you may not find what you're looking for the first time around, the data is available for you to reinterrogate or to perform retrospective data analysis. Since this is such an important topic, and you've heard this several times during the last presentation, I want to speak a little bit more about accurate mass. What is accurate mass? Well, for those of you who haven't experienced this, accurate mass is the ability to make mass measurements past the unit decimal place, being able to go several decimal places beyond what we traditionally use for a measurement. So, for example, if you're used to GCMS, you may be used to seeing peaks at, let's say, a mass-to-charge ratio of 690, as opposed to 690.98543 out to 3 or 4 or even 5 decimal places. That's what we refer to as accurate mass. And rather than drag you through all the mathematics behind it, I'll provide you with this piece of nomenclature which will help to ground us through the rest of this discussion. For small molecules, generally speaking, one digit in the third decimal place is approximately equal to a mass accuracy of 3 parts per million. So if you hear somebody talk about, oh, we have a mass accuracy to 3 parts per million, you're typically talking about accuracy to 3 decimal places. 1 part per million, you're going down to maybe 4 decimal places and so on. Why is this important? Well, when you're using accurate mass to identify an unknown, having a higher degree of resolution with regard to accurate mass, having better accuracy in your mass measurement, limits the possible number of formula that can be associated with that measurement. So let's take a common compound, reserpine, which is used as a check standard. This holds true for any type of toxicological compound as well. Reserpine would have a nominal mass of 609. Its theoretical mass is 609.28066. Now, if you were to take this compound and run it on a unit mass resolution mass spectrometer, let's say a GCMS or an LCMS, and you measured a mass of 609, this would give you a mass error of about 165 parts per million. And if you were to look up mass 609 in a table or in a database, you would find that there are over 200 possible compounds that have a molecular formula containing carbon, hydrogen, oxygen, and nitrogen that could possibly be attributed to a mass of 609. So that gives you quite a vast universe to work with. However, if you improve your mass accuracy, if you're able to make measurements with a mass accuracy down to 10 parts per million, now there are only 13 compounds that have a molecular formula that can be attributed to a compound of mass 609.2. If you go down to 3 parts per million or 2 parts per million accurate mass, now there's only 2 or 3 or 4 compounds that can be attributed to the molecular weight of 609.2806. And this makes it much easier for you to identify unknowns when you're dealing with this type of a problem. Now, of course, to complement this, not only do we have the ability through the TOF to provide accurate mass data, which results in your molecular formula, which in turn shrinks down your universe of potential unknowns to a few handful of compounds, but we also have the MS information and the fragmentation pattern from the Q portion of a QTOF to further enhance our identification. At Agilent, we offer 2 different series of platforms, the 6200 series TOF instruments and the 6500 QTOF LCMS instruments. These typically have a mass accuracy of better than 1 part per million, which, again, is important in helping to discriminate between compounds of similar molecular mass. Provides for very rapid data acquisition for high-throughput workflows. And with our find by formula algorithms, enables you to confidently identify the peaks that are showing up in your mass spectrum. And I'm going to give you an example of this derived from an actual case study. In addition, these products provide with high resolution as well as high sensitivity to enable low-level determinations in fairly high complex matrices. So here's an example of a case study. This was a 43-year-old male who was found dead in the basement of a home, suffered from diabetes, not a known drug abuser, but a history of heavy smoking and alcohol abuse. A sample of venous blood was collected and sent to the laboratory and run on a QTOF instrument, an LC quadrupole time-of-flight instrument. Here's what the mass spectrum looks like. If we go ahead and we run the find by formula algorithm and we focus in on, let's say, the center of this mass spectrum, you see something that looks like this. And so for these peaks, we've identified the molecular formula attributable to the molecular weight for each of these peaks. And each one of those molecular formulas can be attributed to one or two or possibly three different compounds. And the question becomes, well, which one is it? So this is where the quadrupole piece of the QTOF comes into play. So if we look at the green peak, the C17H21NO4, it could be cocaine, could be hydromorphanol or phenteranol. We take a look at that and the fragmentation of that particular compound, and we're able to do a comparison with our library and definitively identify that particular peak as being cocaine. So in this particular case, it was a fairly identifiable drug in terms of cocaine, but it certainly could have been a designer drug, a synthetic cannabinoid, or a bath salt as well. This technique has found its way into many laboratories, both here in the United States, in Europe, and in Asia Pacific, and has been cited in dozens of literature references. And for you today, I've done a short survey of the literature just to give you some sense as to what laboratories are saying and the conclusions that they're coming up with as they begin to employ these techniques into their laboratories. Here's some of the initial work that was done on a time-of-flight instrument, LC-QTOF, came out of the Institute of Legal Medicine in Germany, where they used LC-QTOF for the purposes of systematic toxicological analysis. This was the flagship paper, and subsequent to this, there have been roughly half a dozen or more papers published out of the same institute demonstrating specific examples of how they've used the workflow enunciated in this particular work to specific problems within their laboratory. This work came out of Harris County Institute of Forensic Sciences in Texas back in around 2013. Validation of LC-TOF-MS for screening of drugs and metabolites. And they concluded, quote, in a forensic toxicology environment, it is critical to maintain an expansive and comprehensive screening method, unquote. And furthermore, they concluded that the use of LC-TOF-MS technology helps to address this need by providing fast, broad, inclusive scans that can be retrospectively data mined as new investigational clues emerge. Some further work, this time coming out of ARUP, where they used a TOF instrument to examine over 100 false positive amphetamine species that had been previously characterized by LC triple quad and immunoassays. And as a result of the study, a couple of additional conclusions that they came up with alongside with their characterization of these false positive results were, number one, that full-scan, high-resolution, exact mass and retention time data enables sensitive detection of drugs and metabolites that may not have been identified by a traditional targeted MRM, LC, MS approach. One of the other advantages of a TOF or a QTOF in terms of being able to do these broad-based screenings is they're not limited to the number of transitions like an LC, MS might be, or LC triple quad. And so you truly do have the opportunity to scan the entire contents of the sample as opposed to being limited by the number of targets that you specifically call out within your method. Secondly, it was found that this technique also provides the ability to process data for new compounds as additional information or standard material becomes available. And we saw this in the past presentation where there are some examples of how using a screening protocol can help you identify even some of these new designer drugs that are being flooding out onto the market today. And there have, in fact, again, been publications discussing this in more detail. This one comes from the Russian Federation, talking about identification of and documentation of analytical properties of new synthetic cannabimetrics using LC-QTOF. And what they found was that in the investigations reported, a series of compounds from a new class of synthetic cannabimetrics were identified, making possible their reliable identification during routine forensic examination. A common problem that we all face in laboratories today, when you're up against an unknown, it's not showing up in your target screen. You need to identify it and perhaps begin looking for it on a more routine basis if it's something that's going to start showing up within your particular jurisdiction. And so with that, I'm going to conclude by once again iterating some of the advantages of considering whether it be LC or GC, TOF or QTOF, for broad-based screening of both targeted and these unknown samples. These techniques do provide the opportunity to do characterization of targeted samples to extensive libraries, the libraries that have tens and 20 and 30s of thousands of compounds in them that far exceed what you can do with an LC triple quad, yet at the same time, through accurate mass and through the fragmentation patterns, be able to characterize complete unknown. The fact that you're getting all the data all the time allows for retrospective data analysis or reinterpretation of data should you need to go back and find something that perhaps was missed in the initial screen. And something that we haven't talked about overtly was that this offers the opportunity for perhaps collapsing multiple protocols for screening into one or two protocols rather than doing immunoassay, doing GCMS, doing LC triple quad, and doing LC QTOF. Perhaps there's an opportunity here for collapsing those workflows into a streamlined process that allows you to do broader-based screening and yet in a shorter time period. If you're interested in learning more about this, you can, of course, look at the references that I've cited within the presentation. In the resource section, there will be a link to the Agilent website around the technologies, around the libraries that are available, and also an additional webinar that was presented by several of our customers on the use of LC-TOF and QTOF for screening of unknown samples. And with that, I thank you for your attention.
Okay, thank you very much, Tom. Our final speaker of the day joins us from LabConco. Kelly Williams is the product manager for the forensic product line at LabConco Corporation. She has over 16 years of experience as a product manager of laboratory equipment and specializes in new product development. Kelly has been involved in several new forensic lab construction projects over the last 4 years, and in addition to project management, she has experience working in a molecular biology lab studying the parathyroid and other endocrine glands. Kelly has a degree in biology and an MBA. Thank you for joining us today, Kelly.
Trevor, thank you for the kind introduction. And right now I'm going to take it a little more away from the instrumentation side of it and get more towards the evidence processing. And I want to thank everyone for joining us today. I want to share with you a new type of glue for cyanoacrylate fuming, as well as some new developments in the fuming equipment that is used for the cyanoacrylate fuming. Cyanoacrylate fuming, often referred to as CA fuming, is a common method used to develop and preserve latent fingerprints on evidence. In crime labs, CA fuming is often the first and most frequent test performed on evidence. This technique is popular because latent prints are a very effective means of identification, and CA fuming is a procedure that is relatively easy to perform, especially when you're using an automated system. One of the biggest challenges with superglue fuming is that it can be hard to see when the prints are developed. They can be very faint even if the fuming is performed well, and they do not show up under forensics light sources. Latent fingerprints developed by cyanoacrylate fuming often lack contrast. Therefore, further enhancement is required, such as dye staining and not so frequently powder dusting. Dye staining or powder dusting aims at improving contrast and at increasing the legibility of details, yet their use at times may be limited. Indeed, powder dusting may not be effective due to unexpected adherence to the background and poor affinity of the superglue. In the same way, staining process can dye a whole semi-porous surface, or it may wash away the fingerprint marks. Over the years, scientists have attempted to discover a substrate that, when added to the chemical composition of superglue, would automatically fluoresce when it turned to a gas. The goal was recently achieved with the development of lumicyano. Lumicyano is a new luminescent cyanoacrylate. Lumicyano reduces the steps in the process needed to develop excellent fingerprint marks. CA fuming and excellent fingerprint marks are developed with lumicyano. CA fuming and subsequent staining are reduced to one step without changing the fuming chamber settings, which are typically set to 80% humidity level and 120% fuming temperature. Combining the fuming and dyeing steps into one step reduces the time and eliminates the need for additional chemicals and stains. Lumicyano produces better results by increasing the detail in the fingerprints while preserving the DNA. Many European countries have standardized on lumicyano for cyanoacrylate fuming. Next, I would like to share with you new developments in the design of the automated fuming chambers that conduct the CA fuming. These automated systems make CA fuming much easier by automating the process. It has been proven that the optimal humidity level for the development of the best prints is between 70 and 80% humidity. Fuming systems will automate the humidity level so optimal conditions are achieved for each fuming run. Fuming chambers will also automate the heating of the CA, the fume exposure time, and the exhaust fume time. One particular system I would like to share with you is the Capture BT fuming chamber. This new fuming chamber has many built-in features that improve print quality as well as increase the consistency of the print quality for each fuming run. The Capture BT features two blowers. One blower is for circulating the air within the chamber during the humidification and CA fuming cycle. The fan speed has been adjusted to ensure there is equal fuming in all areas of the chamber. The other fan is for exhausting the CA fumes out of the chamber at the end of the fuming cycle. The CA fumes are captured in a filter system so that the Capture PT does not need to be exhausted to a duct system. The dimensions of the Capture BT have been designed so that the filter and the fan are located on the side of the chamber. The interior dimensions of the Capture BT is optimized, while the controls in the color LCD display are located at eye level. An object as long as 58.6 inches can be easily accommodated in the fuming chamber. This is considerably longer than what can be accommodated in other fuming chambers. The Capture BT stainless steel interior liner make cleaning very easy. During fuming cycles, CA deposits will build up on the interior walls of the fuming chamber. Because the CA has a high affinity to itself, and many new fumes generated will be more attracted to the CA deposits on the walls than the evidence within the chamber, it is important to clean the fuming chamber frequently. CA deposits are removed very easily from the stainless steel walls with stainless steel cleaner. End users simply need to spray and wipe deposits. A built-in humidifier is included with each Capture BT. This humidifier can be certified with a hygrometer and calibrated. This is an important feature for end users that are working toward performance certifications and standards. Additionally, the Capture BT features an exclusive pre-fuming humidity incubation step. The humidity incubation step is helpful when evidence is old or has been in extremely dry conditions. Prints can be rehydrated for an end user selected amount of time before the fuming cycle begins. Recent testing has shown that this pre-humidification step can be very beneficial. The status of the fuming cycle can be detected very easily from across the room. The color LCD display is located at eye level, and the background will change color with a different color designating each stage of the cycle. Filters are easily changed from within the cabinet, so they are easily within reach, and using a ladder is not necessary. The programmable operating system of the Capture BT not only displays the parameters that were programmed of the run, but also displays the actual parameters of the humidity levels and the hot plate temperatures. Knowing the actual conditions and ensuring the parameters are consistent from run to run are very important in producing the highest quality prints available. The Capture BT offers a very large temperature range. The hot plate is programmable from 100 degrees Fahrenheit to 425 degrees Fahrenheit. Up to 20 programs can be stored in the Capture BT's operating system. The first 3 programs are set for high heat, low heat, and lumicyano, the new CA that fluoresces in the gas stage. Their operating system includes a diagnostic mode that will check each function of the Capture BT in a matter of minutes to confirm proper operation and to troubleshoot if a problem occurs. LED lights will flash at the end of the cycle to give a clear indication that the cycle is complete. Activent smart controls allow the exhaust system to run during the pertinent times when the door is open. The exhaust fan can be programmed to run up to 30 minutes after a fuming run, preventing the possibility of over-fuming. End users no longer need to be present at the end of a run and can be free to do other things. Additionally, the exhaust fan that can be programmed to run after the door is opened at the end of the run, protecting the end user during the unloading of the evidence. In the cleaning mode, the exhaust fan runs protecting the end user who may have had their head in the cabinet busy cleaning. Finally, when in the standby exhaust mode, the exhaust fan will run every 2 to 5 minutes, eliminating the CA fume buildup in the airtight chamber that is accumulating from outgassing of the CA deposits. All of these features make up the Activent Smart Controls. An accessory long gun stand is available for the Capture BT. The stand will accommodate up to 5 long guns, and a total of 3 long gun stands can be used in the chamber at once, giving the Capture BT a total capacity of 15 long guns per run. Another accessory that is very useful is the casing holder that will accommodate 44 casings. Casings are loaded upside down, giving an optimal position for complete fuming. The last CA fuming technique that I would like to share with you today is our remote CA fuming at crime scenes. Until recently, the only choices for CA fuming chambers to be used remotely at crime scenes were pop-up tents made from plastic bags, cardboard boxes, or aquariums combined with warmers for coffee cups. None of these chambers provided filtered ventilation, so the end user would have to breathe the CA fumes when the chamber is opened at the end of the fuming run. Furthermore, a coffee cup warmer can be very inconsistent in temperature from day to day and requires a power source. A new portable CA fuming system was recently developed for remote use at the crime scene. A benefit to fuming at the crime scene is that any fingerprints present can be fumed, so they are protected from damage during any handling and shipping that may occur. By fixing the prints on the evidence when it is discovered, crime scene investigators are assured that the prints will remain in pristine condition. The Capture is a new portable CA fuming system that provides a heat source with digital readout and a filtered blower for exhaust. The heat is programmable and ranges from 120 degrees F to 350 degrees F, so the end user can select their desired temperature. With the actual temperature being displayed, end users can be assured of the quality of the fuming and improved consistency from run to run. All of the pieces of the Capture system collapse within itself and fit into one case that is easily transported. This patent design makes field superglue fuming simple, easy, and readily available. Evidence and personnel are both protected. With the ability to power the capture from an electrical plug, inverter, or accessory battery pack, the Capture Portable Fuming System is ready to process your evidence on a moment's notice. Many agencies have added the capture to their mobile crime scene units. This concludes my presentation today. I hope I was able to inform you on new techniques that you will find beneficial. I'd be happy to answer any questions you may have, and I thank you.
Great. Thank you very much, Kelly. And I believe we will go directly into our question and answer session. We do have a number of questions that have come in we need to get through. And Kelly, maybe we'll start with you while I have you. What if you want to superglue fume evidence in the field and it's larger than what will fit in the capture fuming chamber? Is there a solution for that?
Trevor, we have had customers that have used the portable capture to fume larger pieces of evidence. They simply use the capture as the heat source and the ventilation source, and they typically would use a PVC frame and put a bag around it and then tape it to the backside of the platform of the capture. So they're able to fume as large an area as they want and utilize the heater on the capture as well as the blower and the filter. So it is quite versatile.
Great, thank you. And Joe, if you've joined us again, is it possible that you can increase or shorten the duration of the paper spray signal?
Are you talking about the runtime? Yes. The runtime can be varied. I was just choosing an analysis time of 1 minute because it was convenient for a number of applications I was looking at, but you can require adequate data in much less time than that. So the 1 minute was just a starting point. Yes, it can certainly be shortened if necessary.
Great, thank you. And while I have you, how much total solvent does each sample use for the analysis?
The maximum amount of solvent on our particular cartridge is somewhere in the neighborhood of about 100 microliters of solvent. That would be an extreme case. Generally, anywhere from 80 to 100 microliters typically per sample.
Okay, thank you. Now, Tom, I think this next question is for you. If you're using a TOF versus a QTOF, how do you discriminate between compounds having the same molecular formula?
Yeah, that's actually a really good question. If you're using a TOF, you don't have the fragmentation pattern associated with the QTOF due to that secondary level of elucidation. And so there are two ways you could approach this. One way would be if you're using a TOF and you're able to identify a series of compounds, maybe 2 or 3 compounds based on their molecular formula, then you could either use retention time to do the differentiation between the 2 or 3 compounds, or you can use a technique which is called all ions MS. And when you're using all ions MS, you're basically changing the fragmentation voltage within the spectrometer, whether it be a TOF or a QTOF, and you're creating that dissociation pattern within the spectrometer inherently. So even though you may not have a quadrupole as part of the instrument. And so if you're interested in learning more about that, that's actually an entirely different lecture. I'd again point you toward the Agilent homepage where you'd find more information and some technical information on the all ions technique.
Great, thank you. Now, Kelly, our next question says that over-fuming evidence is a concern for their lab. How exactly does the Capture BT prevent over-fuming of evidence?
That's a really good question. How it prevents over-fuming of it is because when you're fuming, you program the fuming cycle and you program the temperature of the hot plate as well as how long it will run. And unfortunately, hot plates don't go instantly back to room temperature when they're done. So if there is any glue left over, it will continue to fume. And without any sort of ventilation that will activate and protect you, you need to be there right when the fuming's done and open the door. When the Capture BT, when it's done with its fuming cycle, it will kick on the exhaust fan, and that exhaust fan will continue to run for 30 minutes. So it gives you a 30-minute window of getting there at the end of the run versus having to get there right when it ends. And generally, and we've done a lot of testing that within 30 minutes that hot plate is back to room temperature. So it basically prevents the possibility of overfuming, which is a key feature to a lot of end users.
Great, thank you. And Tom, again, do the available libraries contain spectra for more recent designer drugs that have been identified? Tom, did you catch that?
Yes, I did. Thank you. With regard to the libraries, that's really going to depend upon the commercial source of the library. In our particular case, we have a collaboration with the International Forensic Research Institute down at Florida International University, and we've managed to acquire the majority of available standards of designer drugs and metabolites that are commercially available today. And those have all been captured in our libraries across the platforms, whether it be GCMS, LC triple quad, or LC QTOF. So in our case, if there's available standard or metabolite, it's captured in part of the library, and we're working now on developing those necessary relationships to get us advanced spectra for materials for which standards may not currently be available.
Great, thank you. And while I have you, does decomposition of compounds present any problems in analysis?
Well, it depends on where the decomposition is occurring and really the context of the question. The technique is going to measure. It's going to be able to analyze whatever is placed into the system. And so if there was decomposition or degradation prior to its introduction, basically what you're going to be able to identify is the degradation products. I'm not quite sure exactly what the context of that question is relative to the analysis. I mean, we will characterize whatever gets placed into the instrument, and so if there's degradation that occurs prior, what you're going to characterize is the degradation products.
Great. Well, thank you. I'll forward that question on to you. Maybe we can follow up a little more on it as well. And Joe, regarding the paper spray, how many cartridges can you load at once for automated analysis?
The magazine is designed to hold 40 cartridges, but it's very easy when you start a run to just continuously add cartridges to the magazine throughout the course of the day. In my laboratory, I may have several hundred samples to analyze, and I can start the analysis and just continually reload the magazine throughout the day while the instrument is running.
Right, so there's no need to shut down and reload.
No. It's as long as there are samples in the magazine, the Velox system knows that it's going to take the sample and do the treatment and analyze the cartridge. So as long as there are cartridges available, it will just continue to run. I know what I have done is set a rather long sequence up in the mass spectrometer to collect data, and then just continuously put cartridges in throughout the day, so that it pretty much would run for 8 to 10 hours.
Great, thank you. Now, Kelly, one of our viewers says that they realize that large area is nice for large cases and big items. However, they frequently do single small items. Is there a smaller version of the Capture BT available?
No, we have been asked that, and if you think about it, the only thing that having a smaller area to fume is that it may save you a tiny bit of glue, because the whole process is exactly the same no matter what you're fuming. So by getting a smaller chamber and not having a larger chamber to accommodate your larger pieces of evidence, you're actually setting yourself up so that you won't be able to fume all the evidence that's coming in. So that has been asked before, and what you would simply be saving would be a 0.5 to 1 gram of glue per run. So there really isn't any benefit from using a smaller chamber versus a larger one on small pieces of evidence. It all gets processed the same. But that was a very good question.
Thank you very much. And I thank you all for the discussion. As I look at our screen, I realize we've made it to the top of the hour and we're through all of our questions. If you do have any further questions for our presenters, please consider reaching out to them directly, as they are the true experts in the field. Their contact information, as you can see, is available on the screen now. And just a reminder that today's webinar video will be available at the link you see on screen. On behalf of Lab Manager, I'd like to thank our panelists today for all the hard work they put into their presentations. And I'd also like to thank our sponsors, Agilent Technologies, Thermo Fisher Scientific, LabConco Corporation, and PitCon 2016 for supporting our Tech Trends webinar series. As well, I would like to thank all of you for taking time out of your busy schedules to join us today. You may wish to join us for our next Tech Trends webinar, which will focus on biological safety cabinets. This webinar will be taking place Thursday, October 29th from noon until 1:30 p.m. Eastern Daylight Time. For more information about this and other Lab Manager webinars, please visit our website at www.labmanager.com. We hope you can join us again next time. Thank you and have a great day.